Hi everyone, it's great to be here today to present and share some of the work we've been doing at Cats Protection. My name's Jenny and I am the feline epidemiologist at Cats Protection and I work within the feline welfare research team. For those of you who may not have heard of Cats Protection, we are the largest UK cat charity with around 210 volunteer-run branches and 34 cat centres, directly helping on average around 150,000 cats every year. And that's in addition to providing other support services and resources for the public. We are UK focused, so whilst some of the research findings are discussed are UK based, the frameworks and tools that we are creating are adaptable and could be used across other areas. I'm going to start by providing a bit of an overview of our population research, thinking about how many unowned cats there are and the challenges associated with that, and how we might be able to overcome them given the right combination of data. Throughout the talk, there will be a common thread around how unowned cats are completely interlinked with humans and their pet cats. And with that in mind, I will then discuss how we can use population models to explore the connections within cat populations. And I'll be using nutrient as an example intervention. So looking at populations, let me introduce a problem which I'm sure you are all familiar with. Large numbers of free-roaming, unowned cats can be found in urban areas. They're sometimes viewed as part of the community and can be much loved by some individuals, but their presence is often contentious for others. They can be regarded as a nuisance or a threat to public health. These cats do not live in isolation. They're a dynamic subgroup of the total cat population. They live alongside and breed with the owned cats, and abandonment of unneutered cats and the unwanted litters provide a persistent source of unwanted cats in the environment. And that can reduce any long-term impact from management, such as TNR, if these processes are not addressed. Consequently, programs that pair trap, neuter, return with community engagement are found to bring about benefits for cats and people in the community. So why are these community engagement programs more effective? Well, in terms of population management in urban areas, trap, neuter, return and trap, neuter, rehome can sometimes treat the symptoms of the overpopulation problem, but not necessarily the cause if cats are still moving from the owned cat group to the unowned cat population. That's not to disregard the positive impact on the individual cat that's being helped by these efforts, but if we're looking at it through a population management lens and where resources may be limited, then TNR is often an imperfect solution. Additionally, whether unowned cats get neutered will depend on the actions of individuals within the community. So for sustainable change, TNR activity should be linked with community engagement to encourage those positive behaviours towards cats, including the continued reporting of unowned cats for neutering and the controlled breeding of the owned population. So we've previously done some research in this area and found community engagement TNR programs to bring about benefits for cats and people in the community. I don't have time to go into this research in any more detail today, but all this work is published open access online, so freely available to all. So this provides a bit of a background around the community engagement work that takes place, and an added benefit of this work at a community level is the detailed data on unowned cats that comes out of it. It is a vast valuable data set when you do community engagement at a local level. So let's use it. So what data did the teams collect as part of their operational activity? Well, we had a lot of citizen science data. So before the teams launched any TNR activities, they engaged with residents. And as part of that, residents were able to make reports of sightings of unowned cats. Additionally, residents completed community surveys which asked about whether they had seen any unowned cats. This is valuable intelligence, but it's subject to error. Neighbours may be reporting the same cat that's wandering between their gardens, so we have this duplication issue. And importantly, an added error that is not as prevalent in more ecological citizen science data is misidentification. We're not just asking residents to report a cat, we're asking them to report an unowned cat. And how can we tell the difference between an unowned and an owned cat? We're trying to differentiate within a species, which at best is not easy, which is why a lot of cat studies of this nature just report on free-ranging cats. So we have a lot of misidentification, so this data is problematic. But what we also have is confirmation of where unowned cats are found or not found, following some robust identification procedures by the teams themselves, such as checking for microchips or using paper collars and door knocking within the community. If we combine these data sets, then we can account for some of these issues in this data, and we can get more accurate estimates of unowned cats. Combining data sets with different levels of reliability is not new. It's an approach used a lot in ecology where not all animals are detected. However, these models were not created to deal with misidentification. So I created a modeling approach that does just that, called an integrated abundance model. So in short, you input the data from the residents and the data from the experts, and it can account for the biases that we've just discussed to provide a more reliable estimate of unowned cat numbers. So I applied this new model across 5 urban areas where the teams had been working. We had around 900 resident reports, over 3,000 survey responses, and then expert data from the community teams from some of those areas. The model is then able to estimate across all these sites the cat numbers, accounting for the likelihood of misidentification or indeed of not identifying a cat when it was unowned. Within the model, we can explore potential relationships between unowned cats and other factors also, so we can start to think about predictors in the environment. Across these areas, we found unowned cats are intrinsically linked to people. So it's linking back to the importance of community engagement in terms of that longevity in unowned cat management. So where there's more people, there's more unowned cats. So if we look across this horizontal axis here, as human population density increases, so does the predicted number of unowned cats. And this relationship is more profound for the more deprived areas, which we can see in blue here. So where areas are more deprived, according to government indices of deprivation, we have more unowned cats. So what we can then do is use these relationships to predict across similar urban areas in the UK. So in doing this, we were able to provide the first spatially explicit estimates of the expected distribution and abundance of unowned cats across urban areas at a national scale, as you can see at through these heat maps here. Densities of cats range from 2 to 57 per kilometre squared. And then we can combine that information to give the total UK urban unowned cat population, which we estimated to be around 250,000. One of the additional benefits of this modelling approach is that we can give some certainty to that number. So we have a 95% probability that it lies somewhere between 157,000 to 367,000 unowned cats. So we can start to understand numbers and distributions of these cats, and we hope to build upon this work going forward. Now we have that statistical tool and the data collection framework to do so. And indeed, if anyone is collecting similar data, then this approach may well be useful in other areas. But what this doesn't tell us is what is causing these numbers. We know cats are interlinked with people, and unowned cats are linked with the owned cat population. To explore this connectedness further, we launched a UK cat population model project. The rationale behind this modelling project is that cat populations are completely interlinked. Cats can move and breed among these different subpopulations, but we have very little understanding of how they influence each other or how interventions may impact all aspects of the network. The aim was then to develop a flexible theoretical tool for looking at cat populations through time to help us consider all these cats in what we do and recognise these cat types and their connections. So what does this model include? It's what's called a matrix population model. So basically a square of numbers that accounts for many different aspects of the cat population. Although the model is relatively simple, it accounts for a range of different factors such as the subpopulations, so whether a cat is an owned cat, shelter, feral or stray. And here I just wanted to flag the terminology, as I'm aware that inconsistent terminology is unhelpful. We have to differentiate between feral and stray for modelling purposes due to the different pathways that they may take through this matrix. So in this context, a stray is a previously owned socialised cat that is rehomable, whereas a feral cat is unsocialised and unsuitable for a transition to a home. So in order to model them appropriately, they were required to be put into these subgroups, but I'm aware of the complexity in unowned cat terminology, and this is going to be considered in future research projects. The model also accounts whether a cat is neutered or not and the age of a cat. We can then predict how many cats are in each subpopulation through time based on whether they're surviving, the number of kittens they have, whether they are neutered, and the probability that they move from one subpopulation to another, which is termed transition. And this can include whether they are relinquished to a shelter or the rehoming rate or the probability a cat strays, for example. I've also included seasonality in breeding to account for those kitten seasons, and an owned and shelter carrying capacity, as the number of spaces in homes and shelters will be limited. So this is in essence the nuts and bolts of the model. This framework was published last year, and within the paper we had a couple of examples that highlighted the importance of this connected nature of cat populations that I briefly want to talk you through. So we focused on owned cat neutering and found that just changing aspects of this single parameter had profound effects on all subpopulations. First, we looked at neutering prevalence, so low, medium or high owned cat neutering. These figures show the predicted numbers of cats over a 10-year period with the same starting populations. You can see here when fewer owned cats are neutered, as highlighted by the green line here, we get population increases. So we get these population booms, and especially for the stray population here in the top right figure. So we can see a lower neutering rate of the owned cats, and we've got increases in our unowned cat populations. So this theoretical model starts to provide explanations of why we find more unowned cats in deprived urban areas due to the lower neutering rates of owned cats. We also looked at prepubertal neutering, so neutering cats before puberty so they do not have a litter of kittens. So again, just focusing on the owned cat population by way of example. So here the figures are a bit different, so please bear with me. These values here represent population growth rates over 10 years. So any number above 1 is a population that's growing, so you're ending up with more cats, and any number below 1 is a population declining, so fewer cats. And the different colours here represent the different neutering prevalences I just discussed that we may see in communities. So the green is low, the red is average, and the blue is high. So let me talk you through this. So if we focus on these green lines, we have where we have low neutering prevalence. You can see for all populations, we have owned, stray, feral, and shelter. You can see all these green lines are lying above 1. So it's basically saying where we have low owned cat neutering prevalence, we're having population increases. However, the magnitude or extent of this population growth depends on the degree of prepubertal neutering of owned cats. So if only 5% of owned cats are neutered before 6 months and we have low neutering prevalence, we have an 8-fold increase in the population size for stray cats. However, if we have the same neutering prevalence, but we increase this to 50%, we only have a 5-fold increase in the stray population. So if we don't have the resources to increase neutering prevalence, it could still help to shift the ages of cats neutered to be younger. It's not just about neutering more, it's about neutering at the right time. If we look at the average neutering rates in red here, we can see that just shifting the age of neutering of the owned cats can determine whether a population is in growth, like it is here, or in decline or stability, as it is down here. So when fewer owned cats are neutered prepubertally, despite average overall neutering rates, we're still having a big boom in this stray population. However, the same numbers of cats are being neutered, but more are neutered prepubertally, and we have a reduction in population growth. So our unowned cat population isn't increasing. So overall, this example highlights how the connectedness of all these populations means that just one intervention in one subgroup can be hugely important on all facets of cats in our society. And additionally, how benchmarking by neutering prevalence alone, although it's a really important metric, can hide some hidden complexities. Actually, the age of neutering that underpins that is equally important. Whilst this framework is published, this modelling work is a long-term endeavour. So we've got many gaps to fill, and we're continuing research projects in this area. Finally, I've been speaking a lot about populations, but underpinning this are the people and the cats. So continuing thinking about prepubertal neutering, I just briefly wanted to signpost to some other work we're doing looking at age of neutering on cat welfare. Whilst the model and population studies can start to guide the relative impact of interventions, we can't lose sight of the individual. So prepubertal neutering is an area that we've looked into in some detail. Although it is recommended by UK veterinary and animal welfare organisations, it is not adopted by all veterinary professionals. So we've carried out some work to understand barriers and to fill some data gaps around this. So if you want to find out more about this, please check out Ray, who's my colleague at Cats Protection, her talk that is kindly being hosted by ICAM as part of this conference series. So to summarise, unowned cats in urban areas are completely interlinked with people and their pets, meaning there is value in pairing unowned cat management with community engagement. An additional benefit is a detailed community level data collected, and I discussed a statistical tool we have developed that enables us to start to deal with the challenges associated with estimating unowned cat numbers and the issue of misidentification. From this, we were able to estimate the numbers of cats across the UK urban areas, and we hope to continue to fill data gaps across the UK landscape. It also highlighted how cats and humans are completely interlinked and how the fluidity of cat populations is really important in their dynamics. I highlighted how tweaks to neutering in the owned cat population can have really important impacts on the unowned cats in our society. And again, we hope to build and improve this framework to ensure we consider all cats in what we do. Finally, to say a massive thank you to you all for listening and to ICAM for having me. I'd be happy to receive any questions, and if anyone has any questions following today, then you're very welcome to reach out to me directly too. Thank you very much.